Okay, grade 8, but let us get into this whole equations fun situation. So you did equations on Monday with teacher Jen, and you looked at some of the basics, and we're going to recap that, but we're also going to build on that, like Yolanda says. So the really important thing to remember with equations, whenever you are solving any equation, is you need to remember to use inverse or opposite operations. Okay, so I use the word inverse. It means the same thing as opposite. If you are wanting to solve an equation, you have to be able to do that, because in order to solve an equation, we are needing to like move terms over the equal sign. We're needing to get rid of fractions, etc., etc. So inverse or opposite operations is really important for equations. So if we start with our first one, just nice and easy to ease us in so that we remember what we spoke about on Monday, we've got x plus 6 equals negative 3. So quickly on the chat, I want to see all those answers for what is x equal to. If x plus 6 equals 3, what is x equal to? So basically solve the equation for me. Good, guys, well done. So if we use those inverse operations, we know that we would have to say, or we would have to subtract 6 on both sides so that we could get x alone. So we'd have to subtract 6 on the left. But because we've done something on the left-hand side, we need to do exactly the same thing on the right-hand side. The plus 6 and the minus 6 essentially is 0. So we're left with just x on the left. And so yes, x is equal to negative 9. Okay, so that's the idea of inverse operations. Use the opposite operation and you should be able to solve for x. So now what we need to look at is what happens when you've got x's on both sides of your equal sign. So like something we have here in question 2, please don't stress, I will make this smaller so you can screenshot 1 and 2 just now. So when we have variables on both sides of our equation, essentially it's very easy. All we need to do is we want to get x's to one side. So get variables to one side, and it doesn't matter which side you choose to move them. I always choose the left because I like my answer to have x on the left. So I will always move my variables to the left, and you get your constants or your numbers to the other side. So if you put in all x's on the left, numbers should go on the right. And this is again where our inverse operations become really important. So if we look at this question 2, the first thing that I see is I want to get this positive 2x over to join 3x. I need to use my inverse operations, which means it will become minus 2x because it's moving over the equal sign. The next thing that I want to happen is I want to get this negative 10 over to the right-hand side. And again, because I have to use inverse operations in order to move terms over the equal sign, I'm going to add 10. So what I end up having is on the left-hand side, I've got 3x minus 2x because I've brought it over. And then on the right-hand side, I've got 10 plus 10 because I brought the negative 10 over. 3x, or rather now what we have is a situation where we have these like terms here. And because we know they're like terms, we can add and subtract them. So 3x minus 2x is x, and 10 plus 10 is 20. And so we've solved for x. Now, grade 8, what's really important as well is that you don't have to sit and like be worried about whether or not your answer is correct. You can check yourself. And we can check through substitution. Now, you don't have to show your check. You can do it quickly on a calculator. You can do it on a rough piece of paper. That's fine. But you can check. And what you're checking for is that the left-hand side is equal to the right-hand side. So if I substitute, I would have 3 times 20 because it was x, so I replace all x's with 20, minus 10 is equal to 2 times 20 plus 10. So we know 3 times 20 is 60 minus 10. And on the right, 2 times 20 is 40 plus 10. 60 minus 10 we know is 50. 40 plus 10 we know is 50. Because the left is equal to the right, I know that I have correctly worked out my x value. So grade 8, what's really important here and what you need to take away from this is that when you are sitting at the end of your test and you've got 10 minutes left to what you're supposed to be doing is check, this is how you check your equation answers. You substitute in and you make sure that your left-hand side is equal to your right-hand side. Right, so I'm going to stop there. I'm going to make this a bit smaller. If anyone has any questions, now is the time to raise your hand. Otherwise, we're going to have a look at another example. No questions, grade 8? Good. Again, if you decide you do have a question, you are welcome to put it in the chat. Right, but let's have a look at another one. So here we've got 9x plus 3 equals 7x plus 13. So what I'm actually going to do is I'm going to make that smaller. There you go. You can still see 2. I want you to try and solve for x in question 3. So use what we spoke about in question 2 about getting all x terms to one side, all numbers to the other, and I want you to solve for x. So what is x equal to in equation number 3? Remember those inverse operations? So remember, the second you move things over your equal sign, the sign has to change. If you're not sure, remember I've shown you how to check your answer. Use the check method. Make sure that the left-hand side is equal to the right-hand side. You have it available. You know how to check. Use it. I'm going to give everyone another minute and then we're going to have a look. Good. It's because you can check, you should always be 100% sure about your answer. Right, let's have a look. So we've got 9x plus 3 equals 7x. So again, what we want to do is we want to take the 7x and we need to bring it over. So it's going to become minus 7x. And then we want to take the positive 3, bring it to the right, so it will become negative 3. So as we set that up, the 9x stays where it is. We have no issue with that, but now it's 9x minus 7x because we brought it over is equal to 13. And because we're bringing that positive 3 over, we've got 13 minus 3. So 9x minus 7x is 2x. 13 minus 3 is 10. Now, guys, remember, our goal is to solve for x. So we want that x by itself. What that means is that we don't want the 2 in front of it. So what we need to do is we need to go and use our inverse operations and get rid of that 2. Now remember, this is saying 2, times x. So we can use times. 2 times x. The opposite of multiplication is division. So I need to divide this side by 2 so that those 2's essentially cancel. But if I do that to the left-hand side, I need to do that to the right-hand side. And so what I get here as my x value is that x is equal to 5. Sorry. Now again, grade 8, check yourself. If you're not sure, use the check. The check is there for a reason. Very quick check. 9 times 5 plus 3 should be equal to 7 times 5 plus 13. 9 times 5 is 45, so 45 plus 3. 7 times 5 is 35 plus 13. 45 plus 3 is 48. 35 plus 13 is 48. It's equal, so x equals 5 is correct. Right, so those of you who had x equals 16, I think the 16 came from this incorrect bringing over of the 3. Please remember it was positive 3. Opposite operation, it becomes negative 3. That's really, really important. Right, so screenshots. Does anyone have any questions before we move on to the next one? You can raise your hands if you do. And those of you who didn't get this answer correct, I hope that you have marked your answers. You understand where you've gone wrong. So hopefully we don't make the same mistake. Cool. Let's have a look at another. So if we have a look here at question 4, it looks a bit overwhelming, but we can sort this out. Okay. So let's start by looking just at the left-hand side. So ignore everything else for now. Let's look at the left-hand side. The first thing we need to see is the fact that I actually have like terms. This minus 3x and this minus x are like terms. So let's just add them together. Why on earth have more terms than we need? So negative 3x minus x actually gives us negative 4x, and then we have the plus 2. So I've simplified the left-hand side. Makes life a lot easier. If we now go over to the right-hand side, we've got negative 3x minus 8 minus 2x. Again, what we need to see is that we've got like terms here, and why on earth have more terms than we need to? Let's simplify that. Minus 3x minus 2x is minus 5x, and then we still have the minus 8. And this is also in our equation. So all we've done is we've neatened up each of the sides so that this is a lot easier to work with. So if you have like terms, add the like terms, make life easier. If you don't, you will still get the same answer. It just means that you're working with more terms than you need to. So now we do exactly the same thing. We're going to bring all x's to the one side, bring all the numbers to the other side, and we're going to solve for x. So I want you guys to finish this one off for me. I want you to solve for x and tell me what x is equal to in this question 4. Remember your inverse operations or opposite operations? And give me an answer for what x is in question 4. And grade 8s, remember, if you're not sure, substitute in, make sure the left is equal to the right. I'll give you one more minute. Guys, please be very mindful of what operations it is that you're using. So are you timesing? Are you adding? Are you subtracting? We don't want to use the wrong operation. Okay, so what we need to see here is, again, we want to take this negative 5x and bring it over to join the 4x, the negative 4x, sorry. So that needs to change its sign and become plus 5x. And in the same vein, we want this positive 2 to now go and join the negative 8. So inverse operations or opposite operations, it needs to become minus 2. So we will have minus 4x plus 5x, because we brought it over, so the sign changes, is equal to negative 8. And then because we're bringing that positive 2 over, it becomes minus 2. So minus 4x plus 5x is positive x, and minus 8 minus 2 is negative 10. And so x is equal to negative 10. So please be careful. You're not multiplying the x terms. You are not dividing them. You are just adding and subtracting. You're working with like terms. All right. So take your screenshots, and then we'll have a look at another. If anyone has any questions, now's the time to ask as well while we're taking screenshots. Otherwise, like I say, we can have a look at another example. Oh, right. Oh, run out of examples. Right, let's have a look at another. Right, so I want you to try question 5 for me. There's question 5. I've just put it in there. Let's see how we go. Remember, you're solving for x. We want to get all x's to one side, all numbers to the other side. And like I say, we're solving for x, so we want to get x alone. So you're trying this one by yourselves. Answers in the chat once you've done them, and then we will go through it in a few minutes. And remember, guys, when you get an answer, if you're not sure, substitute in and double check. I'm going to give you one more minute. Keep those answers coming through. You're doing really nicely, grade 8s. Right, guys, let's have a look. So first things first is that I see on the left-hand side, I have like terms. I'm going to add those or subtract them. 4x minus 3x is just x. So I've got x plus 5 is equal to 5x plus 1. So the first thing I want to do is I want to take the 5x and I want to bring it over to join the x. So it's going to become minus 5x. And the next thing I want to do is take the plus 5, bring it over to join the 1. So it's going to become minus 5. So what that means is that on the left, I've got x, and then bringing over the 5x minus 5x. And on the right-hand side, I've got that 1 that still remains there. And I'm bringing over the positive 5, so 1 minus 5. X minus 5x is negative 4x. And 1 minus 5, negative 4. Now you can probably sort of solve it from there, but so we can see the operations, or the inverse operations rather. I don't like the negative 4 in front of the x, so I'm going to divide both sides by negative 4. That gets rid of the negative 4, so I'm sorted. But if I do that on the left, I have to do it on the right. Negative 4 divided by negative 4 gives me, oh, sorry, there's a massive truck outside, gives me positive 1. And so here, x is equal to 1. Sorry, I ran out of space at the bottom there. Alexander, what happened to the 4? I'm not sure which 4 you're talking about. If you are referring to this coefficient of 4, remember 4x and negative 3x are like terms. So 4x minus 3x gives me x. And so by adding the like terms, I just get x. I hope that makes sense. Okay. I don't need to, so telling me you don't understand anything, unfortunately, doesn't help me. I need to know exactly where it is you got confused. Okay, so I'm going to unmute you. Try and tell me exactly where you got confused, because this question is basically the same as the last question. Are you there? Donna, are you there?
Adonna, you just have to unmute on your side, hey? I've tried to unmute you. There's a pop-up that comes on your screen. Just click on it. No, still not surviving. You can also type, write your questions or your answers also on the chat. There we go.
I don't know. I'm not hearing you. I'm not too sure. We might need to double check your audio connection. Try send me a message or send a message on the chat or send you Linda a message, and we'll try and help you with whatever it is that you're confused with. Okay. Okay, guys, you should have been taking questions. You should have been taking screenshots. I'm going to give you 30 seconds. Otherwise, we're going to take a brain break. Righto. Right, so brain break for today. There we go. You know the drill. We are going to wait for the person to give us the answer to this final equation down here. Fortunately, I do not know my Pokemon as well as maybe some expect me to, but anywho. So that last equation, I want to know what its value is. First one to get it right on the chat will explain it for us. Okay, so
Let's
this
go,
is
my people.
we're
Yeah,
solving
sorry.
equations basically. No. We're solving equations. Like Yolanda says, we can do this. We can think about this algebraically. We can solve the equation.
Yes, I wonder how long it will take you guys to find an answer. I'm just timing you so I can tell you. Let's see who's the first one to get it right. Nope, it's that 21 on fire. Next try. Let's see. Keep trying. Remember, you need to use. But no, I'm with you. The joke. It's the joke of the day. Said though, the reason I didn't start laughing is because I laughed at the other class. We had the other class, so I also laughed at it. Yes, Kamba. Ah, Kamba, do you want to raise your hand so you can explain to us? Well done, man. Well done. Please raise your hand so you can explain to the rest of the class if you don't mind. The stage is now yours. Let me unmute you. You can explain to us.
Yeah, we can hear you.
So to get the answer for like the Pikachu one, it is 6 plus 6 plus 6 equals 18. And then for the second one, it's 3 plus 3 plus 3 equals 9. And then for the third one, it's 3 times 3 minus 3 equals 6.
Good.
So the last one is 6 times 3 minus 3 equals 15.
Excellent. Well done. So guys, remember, I always say this to you, BODMAS. So here in the second one, exactly as Canva said, 3 times 3 first, that's 9, then minus 3, that gives you 6. As Canva told us, 6 times 3 gives us 18 in the last step, 18 minus 3 gives us that 15. So always remember your BODMAS when you're doing these, because if you don't, you're going to get some weird answers. Right, guys, well done. Nice and quick. I am just going to give you another 30 seconds to have a stretch, because that was a very quick brain break, and have a stretch. Isn't there? You can indeed see the joke. There you go. Sorry, everyone. Unfair. It doesn't matter. We all make those mistakes every now and then. That's all right. Okay, guys. So let's have a look. Let's have a look and see what happens when we have fractions involved. Okay, so the thing I want to point out here is that if we are doing division, the opposite operation is to multiply. Okay, same as with the last examples, when we had, let's go over here, when we were multiplying, the opposite operation was to divide. So remember, when we have division, when we have a fraction, our inverse or our opposite operation is going to involve multiplication. So if we look at this first question, we've got 3x over 4 is equal to 6. I'm just rewriting it because I'd like some space next to my fraction. Now, whenever we do have fractions, our goal should be to try and get rid of the denominator as soon as possible. This denominator is essentially telling me I'm dividing 3x by 4. So according to my opposite operations, I now need to times by 4. That will essentially get rid of my denominator and leave me with just the 3x on the left-hand side. But remember, grade 8s, if you're going to times the left by 4, you also need to times whatever is on the right-hand side by 4. So that means we've got 3x is equal to 24. Now that we've done that, we can keep using our inverse operations. Remember, We don't want that coefficient to x, so we need to divide by 3 so that we can get rid of it. But if I'm going to divide the left by 3, I must divide the right by 3. So I've got 24 divided by 3, and that gives me an x value of positive 8. So what's really important to remember with fractions is what your inverse or opposite operation is. The opposite of dividing is to multiply. And so we can solve equations even if they are fractions because we know how to use inverse operations. Right, guys, are there any questions about this before we move on? So take a screenshot. If you've got questions, raise your hand. Otherwise, I'm going to give you an example to try. Yeah? Sorry, I'd said that so quickly. Here, do you have a question? You were unmuted and then all of a sudden muted again. Try again. Okay. I don't know what's happened there. All right, guys. So we are going, or you are going to try another example. Sorry, my math brain has just escaped me for a second, which is fine. It happens. So I want you to try this one that has a star. So 7x over 4 equals 14. Lubanzi, do we always take the denominator and times it by the numerator? So we're not timesing 3x by 4. What we're actually doing here, so if I just take this section and take a little thing, we're saying 3x over 4, and we're multiplying it by 4. Now, technically, 4 can be written as a fraction of 4 over 1. And so that is why those 4's cancel. We are not multiplying 3x by the numerator. If you didn't cross cancel, the other way you could do this is you could say, okay, I've got 3x over 4 times 4 over 1. If you multiplied that, you would get 12x over 4. And through simplification, you end up still with 3x. So we're not multiplying the numerator by the 4. We're just timesing the whole, or we're multiplying the whole fraction by 4 in order to get rid of it. Okay, so we're not timesing the 3x alone by 4. So I can see some people trying the little star one. Have a go. And remember, guys, substitute. If you're not sure, substitute your answer in and see what you get. I'm going to give you 30 seconds. Sorry, I just wanted to erase all of that so I had space. Oh, my nose is itchy. Okay, guys, let's have a look. So first thing, I don't like that denominator 4, so I'm going to times it by 4 in order to get rid of it. But if I do that on the left, I have to do it on the right. What that means is on the left-hand side, I have got 7x is equal to 56, because 4 times 14 is 56. And then remember, I don't want that coefficient of 7, so I need to divide both sides by 7 so that I get x alone. 56 divided by 7 gives us 8. And so for that one, x is equal to 8. Again, grade 8, substitute your answer and make sure you get the correct left-hand side equals right-hand side. Right, so again, take your screenshots. If you have questions, now's the time to raise your hand. Otherwise, I'm going to give you another example to try. Okay. Right, so let's have a look at another. Here we've got 4x over 5 minus 2 equals 14. So what I want us to notice here is the fact that on the left-hand side, I actually have two terms. So my first term is the fraction. My second term is that constant minus 2. So guys, what we want to try and do, the second we have multiple terms, so when we have multiple or more than one term, we want to isolate the term with a fraction. So what that means is, that's weird looking alone. What that means is we want to take this negative 2 and we want to bring it over our equal sign so that we just have the 4x over 5 on the left. Now we know how to do that. If we bring it over, it becomes plus 2. And so we've got 4x. And so we've got 4x divided by 5 is equal to 14. And then we've got that plus 2. Okay. That then means that the right-hand side can be simplified. So I've got 4x over 5. And we know that 14 plus 2 is 16. And now we've got a situation like what we started with in the first two examples. We've got the fraction on one side and our number or our constant on the other side, which means that we can now go and solve for x. So I want you guys to finish this one for me. We've got 4x over 5 equals 16. I want you to finish solving x for me and tell me what x is equal to. I'm glad we're getting it. That's good. And guys, remember, if you're not getting it, that's also okay. You need to ask questions and you need to go and watch the videos. So I'm looking for an answer for x here. Remember, check your answer. You know how to check it. You can use a calculator to check it. It doesn't have to be written out neatly. Just do a quick rough check to make sure you're correct. I'm going to give you another 60 seconds. Still want some answers coming through. Again, double check your answer through substitution. It's a nice, quick, easy check. Okay, guys, let's have a look. So what we have here is that 4x over 5 is equal to 16. Sorry, I just wanted some space. So we know we want to get rid of that denominator. So we times it by 5. It's gone. But if I do that to the left, I need to do that to the right. So I also need to say 16 times 5. That leaves me with 4x is equal to, and 16 times 5 grade 8 is 80. I don't want that coefficient of 4 there. I need to deal with that. So what that means is I need to divide both sides by 4 to get that x alone. And so when we now say 80 divided by 4, we get an x value of positive 20. And so for this equation, x is equal to 20. So guys, even when there's that extra term, or even when we have those multiple terms, we still sort of do the same thing as what we started with. We get the term with the x on one side, which in this case is the fraction. We get the numbers on the other side, and we solve. All right, so take your screenshots. If you have a question, raise your hand. Otherwise, we're going to have a look at another example. You guys are doing really nicely. Any questions, you can raise your hand. Otherwise, we are going to look at another example. Okay, good, guys. So let's have a look. If we now look at, if we now have a look at question 3, we've got 8 minus 2x is equal to 4. Now, what's different in comparison to the ones we've done is that in my numerator, I have got 2 terms. I've got the 8 and the minus 2x. That doesn't change anything though, guys. We still put the same thing. So we still don't want the fraction there. I'm just going to rewrite it so I've got my space. We've still got the fraction, which is divided by 4, and we still don't like that. So what we do is we times by 4. That gets rid of my fraction. Do the same thing on the right, because what I do on the left, I have to do to the right. And so now we've got 8 minus 2x is equal to 16. So what happens is, even when there's multiple terms in your numerator, once you've gotten rid of your fraction, those terms still remain. They don't go anywhere. So the 8 minus 2x is now equal to the 4 times 4, which is 16. And then we solve our equation. So I'm going to give you 30 seconds to give me an answer for this one. This is a nice, easy one. Let's see what we get. So we're solving for x. Let me know what you get x as in the chat. X equals what? And remember, you can check by substituting. Oh, excuse me. Good, grade 8s. Okay, so we're not so keen on this positive 8 just sitting here. So we want to bring it over, which means it's going to become minus 8. So what we end up with then is a left-hand side that's minus 2x and a right-hand side, which is 16 minus 8, because we've brought it over. 16 minus 8 we know is 8. So we've got negative 2x equals positive 8. We don't want that coefficient of 2, so we need to divide both sides by negative 2. And once we've done that, we're able to get x alone. Now, guys, be careful. Positive 8 divided by negative 2, sorry. A positive divided by a negative is a negative, and 8 divided by 2 is 4. So here, our answer is x equals 4. So again, we didn't want the positive 8. We brought it over. It became minus 8. 16 minus 8 is 8. I need to get rid of the negative 2 in front of the x. So I need to divide both sides by negative 2. And so I have negative 4 as my answer. Negative 4, because a positive 8 divided by a negative 2 is a negative answer. Okay, so screenshot this. If you have questions, again, raise your hand and you can ask me. Otherwise, I think we've got time for probably 2 more, but we'll do 1 more and we'll see how we go. Make sure that you're marking. Make sure that if you went wrong, you know where you went wrong. Okay. So guys, I want you, oh, sorry, panic. I want you to try question 5 by yourselves. Okay, so have a look at it. You've got 3x plus 1 over 2 minus 3 is equal to 2. We have dealt with all of these things already. So you've got the tools to do it. Go back to the examples that we've already done if you need a little bit of help. But let's try question 5, and I want answers in the chat. I'm going to give you a few minutes, and then we'll see how you go. Remember those inverse operations. Remember all the things we've spoken about through these examples, and try question 5 for me. Camber and Jason, I'm seeing your messages in the chat. I'm hoping that we're all okay. I saw that there was a sorry, my bad, and we think we did something wrong. Are we all fine? Have we sorted out any problems we maybe had? Yo, guys, you guys are on it tonight, eh? It was quick. Cool, Jason. Good. And grade 8s, remember, you can check yourself. Substitute, make sure your answer or your left-hand side equals your right-hand side. Awesome, Cumber, well done. Oh, it's so cold. I'll give you 1 more minute and then we'll have a look. Okay, guys, let's have a look. All right, so first things first, don't like this -3. I want to bring it over. So that means I'm going to add 3. So that means on the left, I'm just left with my fraction, which is what I want. So I've got my 3x plus 1 over 2 is equal to 2 plus 3. Okay, I think we're all happy that I could write 2 plus 3 as 5. And that's fine, guys. If you don't have to say 2 plus 3 and then do the 5, if you know it's going to be 5, just write it. The next thing that we need to now sort out is the fact that we've got this fraction. So I'm going to times by 2 to get rid of the denominator, but I do the same thing on the right-hand side. So now I've got 3x plus 1 is equal to 10, because we know that 5 times 2 is 10. We're solving, we're making sure that we get x alone. So now again, I'm not a huge fan, or I don't want this plus 1 here. I need to bring it over, so it's going to become minus 1. Again, you don't have to show the subtraction of 1. If you know that 10 minus 1 is 9, you can just write 3x is equal to 9. I don't like the coefficient, so I'm going to divide both sides by 3 in order to get x alone. And we know that 9 divided by 3 is 3. So in this case, as I think pretty much all of you who put an answer on the chat said, x is equal to 3.